So, when you have logarithmic functions, okay, we can start with normal logarithmic functions. Y equals log base A of x. Okay. If I have a base of 10, that's when I can use my calculator. If I do not have a base of 10, I have to either get it to that by using the change of base formula, or I have to rearrange the equation so that I can do a power formula. If I have this, this can also be written as x equals a to the y power. So I can rewrite it if this isn't a base of 10, so that I can solve for what x is. Okay. So this is a logarithmic function with a base of a. My base is always what's in front, either log or what is raised to a power. So if I have log 5 of 125 equals 3, how could I rewrite that? How can I rewrite that?
3 equals
Yep. Not 3 equals, what's my x? No, 3 is not your x. 125 here. 125 equals what?
3
No, it should be changed into a power, something to a power. Think this, what? Yeah, 5 to the third power. Because 5 cubed is 125. If you use a little bit of common sense. The base here always becomes the A. So this is my A. This is my X. This is my Y. X, Y. So you're just rearranging at this point. What happens if I have 2 equals log 3 to the 9th? You got to be able to just look at it and know which way it is. This time, instead, this one's set up just like this one. This one was flipped, but the equation's still the same. You just have to go by where the log is and work off of that. What's your base? No, my base is not 9. Nope. My base is my A. My A is always with my log. What's my base? 3. My base is 3, so something equals 3. This is my
9 equals
Yes, 9 equals 3 to what power?
second.
To the second. X, Y.
You just leave it like that, or can you solve it?
It is solved. 3 squared is 9. It's already, because we got to get used to rearranging these so that we can end up solving some stuff and being able to graph some things. Okay, if I have, if it says evaluate each problem, and it gives you, let's see here, and it gives you log 2 of x equals 32. Okay? If it says evaluate that, then I need to set that up so that I can solve. What am I missing in this equation? Nope, I have my base. What? My y. I'm missing my y. So if I rearrange this, what is my x in this case? 32. So I say 32 equals, and my base is 2 to the y power. So I'm trying to figure out what that y is. Okay? So it's 2 to what power equals 32? 2 to what power equals 32? Or, well, I can do one of two things. I can break this down into a factor
16.
tree.
16 times 2 is
Okay, but I need, how many 2's do I need to get to 32? So 2 and 8, 2 and 4, 2 and 2. How many total?
6, 5.
5. So my y is 5. And that's what they want when they say evaluate. They want to know what power or what is the missing factor that I have in here, because it might not always be the power that's missing. Okay? So when it says evaluate, it wants to know that. So then you would rewrite it as 2 to the 5th equals 32. And this is how they want you to write your answer. So when it says evaluate, I'm looking for the one thing I don't have, whether that's my base, my x, or my y. And then I'm figuring out what it is and then putting it into that form. What if I have log base 3 of x, x equals 1? How do I set that up to solve?
So 1 equals
Yep, 1.
3 y power.
Good, Dakota. So 1 equals 3 to the y power. Now, this you should automatically know. Anything raised to what number gives you 1?
0.
0. So y is 0. Which means if I rewrite this, I have 3 to the 0 equals 1. That's what they want. What happens if I have this? Log base 10 of x, where x equals 1 over 100. How do I set that up? Okay, 10 equals, not 10 equals, well, yeah,
10 to the y.
good, equals 10 to the y. Now, if I have 10 to the y, and my answer becomes a fraction, that means what is my exponent in this case? No, it's a negative. If I have a negative exponent, I have to put it in the bottom. Now, 10 to what power gives me 100? 10 times 10 is 100. So you're saying 10 to the 10th power? No. 10, yes, squared, 10 squared. So I need to say y should equal negative 2, because I know that 10 squared is 100. So if I put negative 2, then I'm going to flip it and put it down in the denominator spot. So I get 10 to the negative 2 equals 1 over 100. So anytime you see a fraction, you're going to have a negative exponent, okay? So that's evaluating. Now, let's talk about evaluating when there's a base of 10. What we're going to do, we're just going to plug it into our calculator. Okay, so evaluating with a base of 10. If I have, all of these are the function of x equals log base 10 of x, okay? So let's start with this. If I want to plug, if x equals 10, what would that come out to be? What does that come out to be? This is all calculator work.
1 E10.
No, it shouldn't be 1 E10.
My thing says 1 E10.
That's not what it should be. It should just be 1.
Right.
Calculator never lies.
Yeah.
You must worship
The log button is right under the x squared button in the first column.
Oh, how do I go down?
Yeah, use the restroom, Peter's law.
Yes, what do you mean go down?
What is it?
You shouldn't have to go log.
1.
It equals 1.
Okay.
Because basically what I'm doing is saying log base 10 of 10. So I'm saying 10 equals 10 to what power, yes? That's what I'm actually saying. So if I plug in my calculator, I get 1. With B, let's try having x equal 1/3. I don't think you need a new calculator. I think you need to learn how to operate your calculator. You're not putting anything in here. You're literally pressing the wrong thing. When you're using a base of 10, you don't have to plug anything else in. Okay, what if I have x equals 1/3?
But is it 1? Yeah, it's 1.
So that means I have log base 10 of 1/3, right? Which is the same as saying 1/3 equals 10 to the y, yes? So log 1/3, make sure you use parentheses on this. What do you get as your answer? No. What? You don't get 1. Did you use parentheses? No. You never plug in the 10. The 10 is already there. When you have a natural base, or when you have a base of 10, it's already in your calculator. You're plugging in log of 1/3. Yes. Negative 0.48. I'm just going to round to 2 decimals. What happens when I have x equals 2.5? Okay, same as writing log base 10 of 2.5, which is the same as saying 2.5 equals 10 to what power?
0.40.
What'd you say, Dakota?
0.40. This is like 0.297, so you round up.
No.
0.40.
0.40. Okay, if you round to the whole, that's fine. 0.40. 0.40. Good. And what if I have x equals -2? Which is the same as writing it log base 10 of -2, or writing -2 equals 10 to what power? So, log -2 gives me what? What?
Gives me an error.
Good, it should.
Okay,
I'm sorry.
It gives you an error, is that what you said?
Yeah,
Yeah, it should.
I'm sorry.
No real thing.
So your answer is just error. You would just write that down because it's not possible to have that.
I'll read it.
Okay? So you're going to have to do it by hand, switching things back and forth by hand, evaluate by hand, and then evaluate with a natural base of 2. The ones that you are evaluating by hand are because these bases right here, okay, are not 10. This base is a 10, but they're still having you evaluate it by hand. You've got to be able to go back and forth. Okay. So then, that leads us to the properties of logarithms. And there are 4. The first one is very simple. It says if I have log base a of 1 equals 0, then that means that a to the 0 equals 1. Okay? That's the same thing that we did right here. Property 2 tells me if I have log base a of a equals 1, because if I have a raised to the 1 power, I'm going to end up getting a. So if the base and the property match, it's 1. The third property tells me if I have log base a to the a of x, okay, equals x, then that means that I can rewrite it a to the log base a of x equals x. And it's going to allow me to cancel things out so I can get a solution. And then the fourth and final property tells me if log base a of x equals log base a of y, if these are the same bases, then those can cancel out to give me x equals y. I get rid of the logs completely if the log and their base are the same when they're set equal to each other. And that's going to allow me to start solving some problems using logarithmic functions. Okay, if I have this, it says solve or simplify, and we're gonna do about 4 different ones. If I have log base 2 of x equals log base 2 of 3, can I solve or can I simplify that one? Can I solve for x? Or can I just simplify what's happening? Yeah, x equals what, Lindsay? 3. These are the same base, so they cancel out, and x equals 3. So I can solve on that one. Okay? Because of my fourth property. They have the same base, so they cancel and they equal each other. What happens if I have log base 4 of 4 equals x? Can I solve for x? Okay, what do you get? If you have to, rewrite this. How can I rewrite this? 4 equals 4 equals 4. 4 equals 4. Well, okay. You're used to the y and x being in different spots. But yes, the x would be what goes here this time. So 4 to what power gives me 4? 1. So x equals 1. Okay? It's the same as this rule right here. If these two things are the same, this should always equal 1. It's property number 2. What happens if I have log base 5 of 5 to the x? Can I solve or simplify that one? What can I do there? What one does it look like over here in the blue?
Number 3.
Number 3. So I need to rearrange it. How can I rearrange it? This is my a. So 5.
Log.
Yep.
5.
5
To the x.
5 to the 5. Yep. Equals x, right? Log. So I have log base 5 of 5 to the x equals x. This should still have an x with it because it's the same thing. Equals x. And that is all I can do. That's as far as I can simplify for now. Later on, we'll talk about how to go further from there. And then the last one says, if I have 7 log base 7 of 14, how can I rearrange that? Or what can I do? 7 log base 7 of 14.
Log 7, 14.
Log 7, 7, 14.
Next to the 14.
Yeah.
Plus
And then
log
put in
plus.
ones up there.
7. That was a 7.
Okay, Linz, you're on the right track. You're saying log 7, and then you're saying,
I'm waiting.
okay, listen. This one's like number 3 still, right?
Yeah.
Where I have, but it's kind of backwards. I have my base raised to log base 7 of 14. So what's it going to equal?
X.
It's not going to equal x. This right here says if this is x, it equals x. So this is what?
14.
What should it equal?
14.
14. And that's how you're going to simplify. So both of these ones, all you can do is simplify for now. Okay? So you have to work that one backwards a little bit. Tomorrow we're going to talk about graphing. Today you're going to work on evaluating.
Yeah.
Can I go to the
Yes.